Laplace transform problem with the use of the Laplace transform table. You can find these online just about anywhere. Okay, so the first thing we're going to do is we are going to solve for this first part of the equation on the left-hand side of the equal sign. So we have x double prime plus 4x. When we look at our Laplace transform table, we can see that it corresponds to the f prime of x, or the f double prime, excuse me, which equals, when we transform it, to s squared big X times s minus s of x, little x, O, or 0, minus little x prime of 0, plus, now we have this 4x right here, and that also aligns with another identity that implies that the Laplace transform of x of t equals big X of s, which in this case would be 4 big X of s. Okay, the next thing we'll look at is the right-hand side of this equation, so the cosine of t. This follows another property of the Laplace transform table, which says that cosine w of t equals s over s squared plus w squared. So we will transform them. So we have cosine of t, and when we transform that with the table, we get s divided by s squared plus 1. Since there is no actual value here, we just imply that it's 1. Okay. Just for visual purposes, let's put these equations together. So, in brackets, we'll put s squared of big X of s minus s of x of 0 minus x prime of 0 x prime of 0 plus 4 big X of s, of s, equals s divided by s squared plus 1. Okay. The next thing we'll do is we will apply the initial conditions. Our initial conditions, as shown, are x of 0 equals 1 and x prime of 0 equals 2. So we will apply those into the equation. So, s squared of big X s minus s times x of 0, which is 1, minus x prime of 0, which is 2, plus 4 big X of s equals, once again, s divided by s squared plus 1. Okay, now when we factor all these conditions into each other to simplify, we find that could stick those together to simplify. So we will do s squared plus 4 times the big X of s minus 2, or minus s, rather, since s times 1 is just s, minus s minus 2 equals s divided by s squared plus 1. Now we're going to solve for x of s. So we have to do a bit of algebra here. The first thing we can do is we can move these two over to the other side of the equal sign. So to start off, we will do s squared plus 4 times big X of s equals, when we move these over to the equal sign, they turn into positive. So we get s plus 2 plus s divided by s squared plus 1. The next thing we can do is divide out the s squared plus 4. So when we do that, we will get big X of s equals s plus 2 divided by s squared plus 4 plus s divided by s squared plus 4 times s squared plus 1. Now, in order to solve for this equation, we also have to do partial fraction decomposition, but I can show that in another video. But when we do partial fraction decomposition, I'll show you the basics. We have Laplace, inverse Laplace of s divided by our s squared plus 4 times s squared plus 1. When we do partial fraction decomposition, we will get inverse Laplace of 1/3 s divided by s squared plus 1 minus 1/3 s divided by s squared plus 4. Now this form actually follows another transform table identity, which in this case we would have to find the inverse. So it actually follows the form of s divided by s squared plus w squared, which, when converted, is cosine w of t. So when we convert it here, we will just take this equation and move it over here. When we convert it, we simply get 1/3 cosine of t minus 1/3. For this one, we're looking at that one right now. 1/3 cosine of 2t. Next, let's look at the right-hand side of the equation. cosine 2t, which we already have converted. So we will take the inverse Laplace transform of s plus 2 divided by s squared plus 4. Which we can easily break up into two different equations which follow two identities. So we will do first one, we will just take s and divide it by the s squared plus 4. So s divided by s squared plus 4 plus the 2, or 2 divided by s squared plus 4. Now, for the first one right here, we can see that it follows the cosine property, which is s divided by s squared plus w squared. We already did that one before, so we can simplify that to cosine of 2t. Next, we'll look at this one. This one has an actual number in the numerator, which is implied that it is w over s squared plus w squared, which equals sine w of t according to the table. So we will add sine of 2t. Now we can plug this all into our final equation, which is x of t equals our equation that we got earlier, which is this one. So 1/3 cosine of t minus 1/3 cosine of 2t. Put that in parentheses to separate the two equations out, plus our most recent find, which is the cosine 2t and sine 2t. So, plus parentheses cosine of 2t plus sine of 2t. And there you have it. You can technically simplify more from here, but this is an acceptable answer.